More AI. We're on it. Okay, so this one was one I said nearly a decade ago. I tried going to the deep learning study group in San Francisco at the medical buildings, lounge areas, and numerous other hacker spaces and groups, and they all kind of gave me a blank stare, which was unfortunate because this would help a lot for lifelong learning and getting smaller and smaller errors rates for really complex systems. This is not something you want to use on an AI that is just like identifying strokes of letters and numbers, handwriting recognition. This is not complex of a data set. The problem you want to apply this to are the problems where things get very hairy, very strange, particular nuanced stuff. You want to apply this to a complex data set. And it's an error detector expert. So the key insight here is that when you're building a neural network architecture for your artificial intelligence, you have your input layer, which bounces around to other layers, cascading upward until you get your output layer. So there's lots of neurons all the way through the thick of this neural network, AI. And as you're training the AI, there's going to be some input values that eventually lead to the wrong output value. You got the wrong answer. So every time your AI is working its way down to lower and lower errors, you're going to be checking for the set of errors. We look at all the error cases as a whole. Were there neurons somewhere in that block of neurons? Any neuron in that block that sees a covariance with the error? So we got some set of erroneous outputs so far. We've been training. We're not all the way down to the maximum that we've normally reached. We've been training. There's a set of errors. We're going to check to see if is there a particular neuron that tends to light up when the network is about to make an error, or is there a neuron that tends to be silent when the network is about to make an error? And there's so many neurons that chances are you're going to find some. Those are error detector neurons. So what you do is you take that neuron, and this is going to be a little bit more complex for you to write the code for this neural network architecture. You can't just plug in 3 lines in TensorFlow. You're going to have to take that neuron and replace it with a whole stack. It's got its own multi-layer perceptron set. So you're going to have to move the tensor out of the way and stick this new block of neurons at the location of that old neuron. And all the neurons that were feeding into that neuron are now going to feed into the input layer of this block. And the output layer of the block is going to be densely connected to the next layer. So that new block of neurons sitting inside of your existing architecture is your error detector expert. And the way you train that expert is you keep the entire rest of the network frozen while backpropagating all the error instances through that expert. So you're going to take the erroneous cases and you're going to feed them through the network. And everything else is frozen. It's not getting updated. Only that error detector expert is being trained. And so it's going to eventually learn how to correctly classify and fix the neural network for some of those errors. And now you can continue training the network. And you do it again, and you do it again, and you do it again. And you'll be building up chunks of error detectors in the network. You'll be continuing to grow new experts. And that can give you lifelong learning, which was what DARPA wanted nearly a decade ago, and they never got. And you guys are still struggling with. So that's how to do that. Just letting you know.